Let's begin with a discussion of the three-species competition model. So this is a very simple and idealized model of the competition of three biological species. It's sufficiently unrealistic that it doesn't apply in real life, but it illustrates in a beautiful way some of the amazing features of three-dimensional dynamical system. So as a preliminary, let's first recall what we learned about two-species competition. So let's imagine we have two biological species that each evolve by logistic growth, but they compete between each other for resources. And so a very simple set of equations to describe the dynamics might be the following. So let N1 and N2 denote the densities of the two species 1 and 2. Then N1 dot might be N1, 1 minus N1 minus alpha N2. And N2 dot is equal to N2, 1 minus N2 minus alpha N1. Each species left by itself would just go to N sub I equals 1 according to logistic growth. But there's a competition quantified by the parameter alpha so that the presence of 2 hinders 1 and vice versa. The presence of 1 hinders 2. So here I'm imagining that this competition parameter alpha is positive. What are the fixed points of this system, which are the same as the long-time outcomes of the dynamics? And there are three possibilities. There can be complete extinction, that is N1 and N2 are both equal to 0. That's an unstable fixed point, but it is a fixed point of the system. There's one such unique state. There's also one species equilibrium. We could have either 1, 0 or 0, 1 are the two possible one species equilibrium where the other species has been eliminated. And then there's two species equilibrium in which N star is equal to 1, 1 divided by 1 plus alpha. So both species are present, but their overall density or overall number is less than 1. It's equal to 1 over 1 plus alpha because of the competition. Now, the point is that for any initial condition, the system will flow into either one species equilibrium or two species equilibrium depending on the initial condition and the value of alpha. And if I start with nobody, then I end up with nobody. From the point of view of dynamics, these possibilities are what might be called dull, dynamically dull. However, when we generalize the system to three competing species, much richer dynamics happens.